data frame, which is basically a table. And then let me do an info. And what this does is it tells me inside my table what columns I have, as well as the number of rows. In this case, we are dealing with a data set of 100,000 entries with the following columns. The columns aren't that important for now, but they will be very, very useful later when we are actually doing data analysis. But for now, I'll just be using this data set as a sample data set to practice your Pandas skills. Okay. Now, a more helpful method that you can use with Pandas is the head command. So data frame, as usual, is your table, and what I want you to do is to do .head on your table itself. And what .head does is it allows you to see the first 5 rows of your table. And it looks something like this. So Pandas is made to deal with data in this format. And if you were to open it up in Excel, you would see something that looks exactly like this. Right? So at this point, yeah, all I'm doing is just opening up a file in Excel, except I'm using Python for it. Okay. And that is a data frame. Now, a data frame, if you were to think of it in your brain, it should look something like this. And what it usually consists of is 3 main types of objects. So a data frame is basically a table that has many rows and many columns. So these are the columns, and these are the rows. What's more unique that you might not see in day-to-day life is the concept of an index. So the index is an ID for each row. In day-to-day, you might think of it like every Singaporean here has an NRIC. So that is the ID for that Singaporean. For Pandas itself, every row has an ID. In the case of our data set, our ID is just the row number. And it can be other things. Right? And that is called the index. To distinguish the index from the rows and columns, the columns are like this. The index is bolded. 0, 1, 2, 3, 4. So that is the index, and the rest of them are columns. And that is the general structure of your data frame. Now, when you're working with data, you often realize that your data set is very, very huge. So for example, the loans.csv that I've uploaded and made available to you is only 8 megabytes. And that's 100,000 rows. The original data set from Kaggle is 400 megabytes with 6 million rows. Yeah. So that is a lot of data, and it's not very useful to work with the entire data set at once. Usually, when you're doing data analysis, what you're actually interested in is a single column, or maybe 1 or 2 columns, or you're interested in a particular row from the data set itself. So the first thing that I'll teach you is how do you get a single row or a single column out from the data set. Yep. So first off, we start with retrieving rows. There are many ways to do it, but I'm going to teach you some of the simpler ways. One way you can do it is df, which is your table, .ilog, the row number. Ilog is short form for integer location, or basically the position of your row. So for example, df.ilog0 gives you the first row, as in like programming arrays. And then df.ilog start:stop gives you a series of rows. So you can try it out in your notebook by copying and pasting this code. So what I have here is the exact same command that I showed you. df.ilog, integer location. And this gives you the first row of my entire data set. You can see here that the loan amount, funded amount, and investor funds are 2,800. If you look at my table, 28,000. If you look at my table, you'll see that this is the exact same row. So all I did was to programmatically access the first row. Next, df.ilog 0 to 5 gives me the first 5 rows. And it is as shown. For columns, it's a bit different. You will not be using .ilog. There are two methods in which you can access a particular column, and that is to do df dot the column name directly. So, for example, if I have a column name loan underscore amount, I would just do dataframe dot loan underscore amount. If I have a column with spaces in between, I would have to use the second one, which is df square bracket the column name. I'll show you examples of both in this notebook over here. So now, we have a loan amount column in our table over here. What I'm going to do is to access only the values in this column by doing df.loan amount. And it will give me all of the values in this amount. Note that Pandas does not print out everything because it's a bit silly to print out 100,000 rows. Okay? Next, df, the same column, loan amount, but now I'm putting it in square brackets, also gives me the same data. Alright? So these are just two ways in which you can get access to a particular column. So I'll just copy and paste this and paste it over here. Now, both rows and columns can be stored in a variable. So in this case, if I wanted to store in a variable a, I would just do a equals to df loan amount, for example. Right? It is just like any other piece of data. Earlier on, I stored my entire table under the name df, short form for data frame. Now I can choose to store my entire table in a variable a. It's just like a number, it's just like any string. Okay? Now that you know how to get out a particular column or get out a particular row, I'm going to teach you how to manipulate columns. Manipulating columns in Python and Pandas is actually really, really simple. If you think about it in Excel, if I have a cell A1 equals to 5, if I want to type in a formula, I would just go to the cell on the right hand side and type in equals to A1 plus 5. And that will give me 10. Right? In Python, all I need to do is to equals to the entire column plus 5. The difference between Excel and Python is that in Python, you're working on the entire column. Normally, when you're working in Excel, you're working on a particular cell. You would equals to something. In Python, you don't really care about individual cells. You care about the entire data set and the entire column in its entirety. Okay? So how it looks like mentally is, let's say right now I have a column A with values 1, 2, 3, and 4. If I add 5, A plus 5, I will get 6, 7, 8, 9 as a completely new column. And I'll emphasize that whenever you do operations like this, you get a new column. You do not need to worry that you're changing your original column. And it's just like Excel, when you do equals to A1 plus 5, you don't change A1. Right? So the equivalent in code itself is actually the same. Remember, it's your column plus 5. And you already know how to get the column. It's basically df df loan amount. This is basically a column. And I'm going to get the first 5 rows. Alright, so my first 5 rows are this. And this is a particular column with only 5 rows. What I'm going to do is I'm going to add 5 to the column. So in this case, 28,000 is the first row. After I add 5 to it, I get a completely new column with $28,000 and $5. Okay? So all I did was to add 5 to the column, and it gives me a new column with the modified details. And that is for adding columns. So what you can do is that you can do a lot of operations. For example, you can do plus, minus, divide, multiply. So those are your common math operations. But very often, what happens is that you don't always have stuff that can be expressed in math, for example. Sometimes you might want to deal with dates. Sometimes you might want to use your custom function. For those that know what a function is, okay, I think everyone should know what a function is, right, for math. So in secondary school, what you learn is that fx equals to x plus 5. So if I ask you what is f2? 7, okay, someone said 7. So a function is basically something that takes an input x and gives you an output. Okay. What you can do is instead of adding 5 to your column, what you can do is you can transform every single value in your column with fx. So the equivalent in Python of fx is def fx return x plus 5. So it takes in an x and it returns x plus 5. Now, so this is your transformation that you will be doing in your data set. So for example, if I have my loan amount in $28,000 and I wanted to make it in thousands, so I want to make it at 28. What I will do is write a def f or divide by 1000, and then my return value is basically x divided by 1000. Obviously, this is a very simplistic example. If you have more complex calculations, you can certainly do it here. Okay? But simply, f is just a function that takes your old data and transform it to a new data. And what you can do is to take this function and apply it across multiple rows. So previously, what I taught you is to create a new column, I will do a plus 5. Is that right? What I can do now is instead of a plus 5, I can do a dot apply f. And what it does is it will take every single value in this column A and apply the function fx to it. So earlier I asked you what is f2. f2 is 7. In this case, f3 is 8, and so on and so forth. So all the apply function does is that it takes your function fx and does it for every single row in your data set. Okay? And that is, in this very, very simple example, my f is adding 5. In a more complex example, if you have a complex calculation, you will also put it here and we will just do it across the entire data set. And both the earlier method that I taught you plus and the other method, for example, fx, all just create a new column. And new columns are important because I'll explain later. Now, let's try it out right now. I have a function called without months. And this is an example of a more complex calculation. Without months is basically a function that finds and replaces the text space months and replaces it with nothing. So if you ever thought in your data set, let's say right now, you are doing a survey, right, at the MRT, and then you ask people to fill in their data. So what happens is that some people, you ask people to fill in their age. What some people might do is they might fill in 5. That is a very obedient survey person. What someone else might do is they might fill in 5 space years old. Alright? And if you wanted to calculate the average age between the 5 and the 5 years old, you can't, because 5 years old is not a number. So sometimes it's very useful to remove certain text, and this is one way to do it. You can find and replace all years old, or in this case months, and replace it with an empty string. So in this case, I have a function without months that takes in a text, for example 6 months, and then when you run it, you would get just 6. So what I did was to find and replace space months and replace it with nothing. That gives me 6. Now, this function works only on a single value, 6 months. But when I'm dealing with an entire data set, I just want to apply it across the whole thing. Now this is the beauty of it. You don't need to know what a for loop is. All you need to remember is df. The column name that I'm using now is term. Before I do the application, let me show you what it looks like. This is what my data set looks like. It's a column where it shows you the term of a loan. 36, 60, so on and so forth. This is not very useful because I would only want the 36. I don't really care about the months. Right? So to find and replace, all I need to do is to apply my function without months. I realize it's really hard to type with one hand. Yeah. Okay. And just like this, I already have a clean data set of 36 and 60. Obviously, this is an idealized setting. In the real world, your data won't be so nice. So So what you need to do is to find and replace for multiple kinds of text. So for example, in the past when I was dealing with my CCA data, what happens is that when I ask for parents' income, some people like to say don't want to tell or don't know or stuff like that. You need to remove all of that if you want to get clean data. And this is what you would do. If you have more kinds of funny text in your survey, all you need to do is just copy and paste this multiple times and change the space months over here. Right? And that's the application of your apply. Now, so far what I've taught you is +5, apply. And this gives you a new column. The problem is that this new column is not useful unless you do something with it. Alright? You can either store this column in a variable. For example, I can do b equals to a.applyf. Or what I can do is I can add it to my original table. In this case, when I'm cleaning the data, what I want to do is to update the term column in my data set with the clean without ones data set. Okay? So to do that, all I need to do is to say, for example, I have a column called issue date. Okay? If I wanted to update this column issue date, what I would do is to do equals to a new column. pd.toDateTime issue date is basically the same column but converted to datetime. So you saw the column just now, issue dates. That was basically 2014 something. Right now I'm converting, all of you are running the same command at the same time. Okay. Yeah, basically I'm converting the entire 2014 to dates in the computer. So do you know in Excel, sometimes when you type the date, you need to click format and then change it to date. This is the exact same thing. And what happens is that after I'm done with that, I'm going to update the existing column, issue dates, with the converted column itself. Okay. Now, what happens is that if you don't want to update a column, let's say right now I wanted to create a completely new column called years, what I could do is I could make use of an existing column and then assign it to it. So this column on the right hand side is the column that you created. You can create it using a+5 or a.apply, and once you have it on the right hand side, you can assign it to a new column in your data frame. So what this does is that it would create a new column, df year. Okay, and unfortunately it's still running, so yeah, just trust me that if I do this, you would see that I have a new year column where everything inside is just the year of that date itself. Right? So you must remember, for issue dates you saw 2014-0 something dash something. If you only want the year, what you can do is take that column, get only the year, and then assign it to df square bracket year. And that is the concept of either creating a column or updating an existing column. It's just very, oh, it's done, magic. Okay. df dot year. Okay. So you see that I have a new column, 2014, 015, so on and so forth. That is just a year. And to prove to you that I didn't pre-create this, remember what I did earlier on? I said df.info. If you scroll all the way up, df.info, can you all find the year? Oops. Okay. okay. To prove that this is not fake news, what I'm going to do is, let's create a new column, year 2. Okay? Alright. And then let's do year 2. Okay, year 2 didn't exist up there, right? I just created it. So year 2, there. Totally legit. Okay. Next, I'm going to talk about the concept of filtering. So filtering is like Excel, you know. Excel, you click on the small funnel, and then you click and then you type in what value you're filtering for. Okay? In Python itself, you don't have the small funnel to click. So you have to write it all in code. But don't worry, the concept is really simple. So for filtering, what you need to do is to think about what you want to filter for. Let's say I have my entire table. When you click on that small little filter button, what happens is that you're clicking on a particular column, is that right? So you go back, think about Excel. You click on the column, the filter is clicking on the particular column. Same thing, in Python, you would think of a particular column that you want to filter by. In this case, I want to filter by the column A. Okay? This is the column that I want to filter by. Next, you need to think of your condition. So in Excel, you can click, you want to filter for greater than a certain value, matching this condition, so on and so forth. In Python, your conditions are almost infinite, but a simple one would be greater than or equals to 3. Okay? So what you will do is you write the column greater than or equals to 3 in Python itself. And A is the column, just to be very clear. Now, after you have done that, all that's left is when you run this, what happens is it creates a new column of FF and TTT. So FF is false, F stands for false, T stands for true. Yeah, and basically in this entire table, for this column, the rows 1 and 2 are less than 3. The rest are greater than 3, for example. Okay? So what happens is, how can we use this column? We can assign it, we can add it to a new column in our table. Just do df square bracket, don't know, into equals to this. Or what we can do is we can use it as a filter. To use it as a filter, just pass in the column, which is this FFTTT, and I named it greater than 3 in the previous slide. So this is greater than 3. I'm going to put it inside the square brackets. Alright? And what that does is Pandas will look inside this column and see which rows are true. And for those rows that are true, it will only return those rows. Okay? So it's very intuitive. I first think of my condition. My condition is the A column greater than 3. And then I pass that condition inside my table. And it will filter out only the rows that I care about. Okay? So in this case, you can actually try it out. So what I'm going to do is, my condition is called DF loan amount greater than 5,000. I wasn't lying about the T and F, except that now they spell it out for you, true and false. Okay? So now I'm going to store in a column above 5,000. Alright, now this is the same column that you just saw, but I hid it inside this above 5,000. Now, this is a condition where my grade is equals to the letter A. So just to give you a sneak preview, the grade column is a column that contains A, B, C, D, E, F, G. Right? Think of it like your school grades. Now, I can create a condition where the particular grade must be equals to an A. So I will use equals equals A. And if I was to store it, I'll just do grade A's equals to, and now these are conditions. Don't forget their names. Two conditions above 5,000 and grade A's. Now, the last condition I'm going to teach you to create is basically saying, what I can do is previously I wanted to see if something is equals, a grade is equals to the letter A. The alternative is I don't really care about a single one. I want to know whether a particular grade is in a set of values. So for example, if I want all grades above C, I would do the grade is in A or B. So this is that particular format. Alright? So above 5,000, grade A's and above C's are all conditions. They are all columns where you have your T and your F. And to apply any of them, all I need to do is to just do df square bracket the condition itself. So for example, I'm going to do df square bracket my condition above 5,000. Okay? And you see that all my loans now are above 5,000. You can scroll down for the rest of your life and you realize that, yeah, this is very close, but still above 5,000. Okay? So all I did was to apply the above 5,000 condition to my table. Now I know for sure that my rows contain nothing below 5,000. Okay? Sometimes it's useful to not only look for one condition, you want to combine conditions together. Okay? What you can do is, okay, let's store the filtered table first. Yeah. If I wanted to combine conditions, I would use the characters and as well as the pipe. For those that don't know, okay, this is a problem I encounter when I teach students. This little pipe, right, is beneath your backspace, and you need to shift. Yeah, look, it's beneath your backspace. Okay? Yeah, so N, I'm pretty sure you all know this. N is the logical N. So just, I think you all should know it by now. If something is true and true, it's true. If something is true and false, is it true or false? False, yeah, okay. So you all pretty know what it is. So if I say that something is above 5,000 and grade A's, it's not N. It means that when I create a new condition called both true, when I apply this both true to my data frame, it will satisfy both conditions, A as well as B. Alright? But if I did all instead, what happens is that if any of the conditions are true, then the row will be shown. Right? So this is how you combine them. You either use and or or. If you want to check that it satisfies all the conditions, you use and. If you want to check whether it satisfies any of the conditions, you use or. Right? If you want to combine it specifically, you need to use your parentheses. So if this and this, or this, or this and this, or this. So this is like a contract. Yeah. And this is what lawyers are paid for. But for the programmers, our conditions are usually really simple. It's just and or. And to prove it to you, I'm going to apply this df both true to my entire column. And you see that all my grades are A. Oh, let me run this. Okay, see? You see that my grades are all A. Why is it all A? It's because both the above 5,000 and grade A's condition is true. Alternatively, let me do a head. If you're wondering what the head does, it just gives me the first 5 rows. Yeah. Alternatively, if I did either true, what happens is that you see that there are some B's and E's sneaking in. And when does a B or E sneak in is when the loan amount is greater than 5,000. Okay? So that is how you filter and how you combine conditions. So now, I only spent half an hour teaching all of you the concept of creating and then filtering. But trust me, this is enough to replicate a very, very huge proportion of your data cleaning and data manipulation efforts. Alright? So if you get an entire data set, what you're going to do is to filter out the rows that you don't want, to create a new column based on another column. You can do it using what I just taught you. Alright? So as your part of your Shopee data challenge, what you might do is to take different data sets and to manipulate them differently. So one example would be if I'm taking, okay, let's say I'm taking MRT data sets. For one data set, it says Jurong East. For the other data set, it does EW19. So what you can do is to replace all EW19s with Jurong East, such that when you merge the two data sets together, you get a coherent, they are linked. Alright, so you can do that with using the without one thing. You just find all EW19, replace with Jurong East, for example. Okay? Other examples include you're trying to filter for certain categories. Let's say right now I'm looking at divorce rates. And what I can do is I can split it by race. So what I'll do is I'll create a table where the race equals to Chinese, race equals to Malay, race equals to Indian, so on and so forth. Okay? And then after that, when I teach you plotting, you can plot them out differently and you can see divorce rates across the different categories. Okay. Now, for today's class, we have come to the second part of our lecture. Well, it's not a lecture, but yeah. It's called plotting. Alright? Plotting is something that you all already know how to do.